Today, we're really happy to have everyone joining us. It's a topic we're definitely excited about here on the Swagger team. And we're really going to be talking about how you can use the OpenAPI specification in your API development and really use that to drive the lifecycle of your APIs. We'll also be touching on tools like Swagger Hub and ServiceV for service virtualization to really show you how you can really accelerate and streamline your API development. But at this time, I'm going to pass off to Keisha and we'll get started. So thanks so much.
Thanks so much for that introduction, Ryan. And I'm joined by Nathan, who's a solution engineer here. And today we're just gonna be talking about the definition-driven approach. And the way I want to structure this entire webinar is first actually, hopefully, drive home the point that it's important to actually start thinking about your definitions, right? Not just from a technical perspective, but really because it has some real big business implications as well. We're going to be talking a little bit about the OpenAPI specification, which is emerged as the RESTful API definition framework in the industry. And from there, we're going to see just from a high level, see how the definitions touches on different aspects of the API lifecycle, all the way from design to virtualization and testing. And from there, we're actually going to take a practical deep dive into actually showing you how this happens using some of the tools which we have. So without any further ado, let's start by understanding the definition-driven API development framework, right? So first of all, APIs have been around for like a really long time. And if you look at, long before even the PC was even created, APIs have always been a great way for different programming frameworks or languages or applications to talk to each other. And if you look at the evolution of APIs, right, it goes from, you can say, before the PC, then the PC came about, then web APIs became huge with Salesforce, and then of course eBay, Amazon, and stuff, and other companies really took it forward. And from there, social media, and especially with social media combined with iOS, like mobile phones, have really taken it to the next level, right? And now we're seeing how APIs actually transform businesses as well using microservices. And so what we're seeing over here in an interesting trend is in the past, when you actually built APIs, you built it for a specific problem, which was, I want to connect different applications together. I want to get these two applications to talk to each other, meaning they were not built for human beings. They were built with data in mind. They were modeled canonically, and essentially they were built so that so that data can be transferred easily between one application to the next. So it wasn't really built for self-service. It wasn't really built for the human. However, with the rise of the platform economy, which we'll talk about in a bit, we are seeing that how modern web APIs, they're no longer like people who are building modern web APIs aren't thinking about it from a data-driven perspective. They're thinking about it from a human-driven perspective. How do human beings come in and actually consume these APIs? And this is both for internal APIs as well as external APIs as well, right? So one big trend we're seeing is, of course, the platform ecosystem. There's all of these different companies which are entering this ecosystem of sorts where you're taking your product and you're essentially extending on its existing foundational services through an API. So, you expose an API and you have third-party developers come in and build on top of your existing services. And of course, this doesn't necessarily have to be third-party. You can also have internal developers come in, use your foundational API product and build on top of that product, right? And this is not something which is isolated. Actually, if you look at the way the internet's history has progressed, you'll notice that platforms have actually been the foundational growth driver for for revenue for products in the internet economy. So far, they've driven over 1.2 trillion euros in sales. The second trend we're noticing, so we've seen the platform economy. We're seeing how companies are taking advantages of APIs and transforming the existing products into platforms. The second big trend we're seeing is this API first approach to product development. So in the API first development, you have your entire product strategy is built foundationally on the API itself, right? You're not even thinking first about the user interface. You're actually thinking about how best you expose your API, which can then be consumed across different front-end clients. So you start with the API layer first. You start with the API interface, and you have your API's backend virtualized or mocked out so that your API layer, your API design, as we'll call it, can actually be, and its functionality can be stubbed out with the mock, which can then be used by front-end developers as well as back-end developers. This way, you're actually minimizing any sort of dependency between the front-end developers and the back-end developers, and you're making sure that your applications are not necessarily constrained by database implementation, right? So your front end applications are not necessarily constrained by that as by how you programmed your backend, because again, primarily you're consuming all of that through an API. So an API first approach as well is something which a lot of these companies are adopting. And we're seeing big companies like, for example, Netflix, Amazon, Facebook, all of these big companies have adopted this essentially in order to create digital transformation within their businesses and move faster. For example, Amazon actually released a mandate in 2002 itself saying that all their different services within their company should be exposed through an API for consumption by internal teams. This is the reason why Amazon, one, works really fast when you're actually using the service in spite of such high traffic, but two, they can actually move really quickly from one market to the next just because of the way they've been, the backend has been architected. So my big takeaways here is, the modern API is no longer data-driven. It's consumer-driven, whether it's platforms, whether it's for internal consumption to the API-first approach. At the end of the day, you want real developers coming in, reusing existing data, reusing existing service sets, and consuming it by themselves without any sort of additional help, right? You want to make sure that this is a scalable process of reuse, consumption, and effectively at some point exposing your data to third-party developers and build on top of your existing product. So it's a huge self-service motion over here, right? And the modern API is built for speed of updation and maintenance. And one other big thing you want to see or make sure is that the modern API has a common vocabulary, because again, you want this to be reused and you want this to be sustainable and you want many people using these APIs, right? And so that's why it's really important to have reusable interfaces that are built on the HTTP standards, if you're going, of course, the RESTful world, that allow for self-service reuse of data and functions, and that's built for the end consumer in place. And that's why the definition-driven approach really comes about. See, in the definition-driven approach, you're actually putting yourself in the end consumer's shoes first. And this end consumer, again, I'm stating this out, putting this out there, it's not just external consumer. It could also be an internal developer as well, right? You put yourself in the end developer's shoes and essentially design the API's interface first before you do any other function, right? This helps in the API first approach when you want to reduce dependencies between front end and back end teams. This helps in the platform economy. And really, once you have the design in place, and we'll show you how you can actually do this in the future in the demo, you can take this design and then create implementation logic. You can essentially maintain this API better, and you can also create a great consumer experience once this API is out there. So remember I mentioned how you need a common vocabulary. The common vocabulary is important because, one, it provides a common framework of thinking when you're actually building APIs internally. Because again, your API development, like any other product, will touch on different aspects of the lifecycle. You'll have your technical writers, you'll have your designers, you'll have your architects, you'll have your developers. All of them are working together on the API. So contract essentially keeps them all in sync and minimizes any sort of confusion or handoff or inefficiencies in handoffs. It's also, the contract is important because, again, because it's the source of truth for your API, you can actually take this contract and integrate this into your workflows. And again, workflows are built not just by human beings, but also by tools, right? Jenkins, for example, is a tool. Your Git repositories are all tools. And so it's important to have this vocabulary or this contract consumable by tools. And so that's why, that's how the OpenAPI came about. The OpenAPI specification is the world standard for defining RESTful APIs. And just a little bit of history, the OpenAPI specification was actually formerly called the Swagger specification. Right? The Swagger specification is essentially this, it was the API definition framework before it was donated to the Linux Foundation and standardized as the OpenAPI specification. Right, so it's and now we are currently in OpenAPI 3.0. That's the current version of the specification. And as I mentioned, right, there's like, it opens up a world of possibilities for you when you're actually building your APIs, all the way from mocking, implementation, to documentation, and creating and during the deployment and runtime. So some quick advantages of the definition-driven approach. One, as I mentioned, reduces interdependencies because you're starting from the API's contract, your API's design, and that keeps all of these different stakeholders in sync. And if you have a virtualized backend or a mock in place, that essentially allows you to also create dynamic virtualized business logic data points in place, which can then be reused by your front-end teams as well as your back-end teams. Faster development and delivery. This is just a byproduct of, again, having reduced interdependencies between different teams. It's also very easy to expand to different interfaces, clients, and views. And this is, as I mentioned, from the API first approach, where you can now, again, you're not constrained by your database or your application architecture. You're actually, because you're starting with an API with the data and the consumer in mind, it's much smoother and easier for you to expand to different front-end clients and interfaces. And finally, with the platform economy in place, if you have a huge data reserve and you think that this data could be used by some external consumers, you can actually expose this through an API. And if you follow the definition-driven approach, you'll actually put yourself in the partner's shoes and create developer-friendly services that motivates other developers to build on top of your existing product. So this is really just saying that, the definition actually touches on every single aspect of your life cycle, going all the way from design to virtualization, code, and testing. And so now let's take a step forward. Let's take a step to really talk about how definitions actually touch on each of these aspects. So let's start with the first one, which is how definitions touch the API's design. So one thing I want to mention is that the definition is one of the a great use case for the OpenAPI specification as a definition framework is to really design your API services, right? So this way, you can actually, when you're designing the service, as I mentioned before, you're putting yourself in the end consumer's shoes and really building a developer-friendly service, but also you're also building services that actually make that it's kind of like a forcing function for you to actually think about your business implications of this API as well, right? So when you're actually designing the API, it's important to identify the organization's business taxonomy, which is the outer bounds of your business, and make sure that whatever API you're designing right now is actually mapped out to that specific taxonomy. So, for example, if you're building an e-commerce application, right? If the e-commerce application as a business will have the outer bounds that includes transactions, searching, cataloging of the items in the e-commerce application repository, as well as maybe invoicing, right? There's like a big taxonomy that's present. And so when you're building out a new service, just the design phase actually forces you to think how this service will actually translate in that specific taxonomy. So when you're designing services, always make sure that you actually think about the tangible outcome of the service to what it can bring to the internal processes. If you're building a service to connect to internal applications together, how is that helping move that process faster? What is its implications to the actual business? Does it help in growth? Does it help in revenue? Maybe both. And finally, does it have any direct impact on the customer itself? So these are just some of the things you need to think about when designing the service. And Nathan, of course, will show you like an example of how the service looks in real on a tool like Swagger Hub. But this, for example, is how the OpenAPI definition would look like for a specific API's design. This is specifically in OpenAPI 2.0 version. So over here, for example, we're showing the metadata of what this API does. So it's just like a high-level description. And then from here, we're showing what are the requests and what are the associated responses. Notice that, again, this is purely human readable, right? It's not like, for example, XML, where it just gets so hard to consume and understand. This is anyone who's relatively decently not too technical, but just someone who understands APIs can come in and understand what this API is supposed to do. Because at the end of the day, what is an API? An API is nothing but a request response cycle for different resources, right? So all this does is it describes what are the requests and what are the responses for each of these resources. And that's just an example of how a design would look like. Design is also important because, again, it keeps all the internal stakeholders aligned. Right? When you have that design front and center, and on the screen, the green box is actually indicative of API design. It actually helps keep all of your different internal stakeholders in sync because, again, this is the contract. right? It tells it tells the architect, it tells the architect that this is what the API is supposed to do, so that he or she can then translate that across his development teams, his or her development teams. And then you have the developers coming in writing business logic. You have QA teams coming in and making sure that this API works by generating test cases against the definition. So it really essentially minimizes any sort of confusion between these different stakeholders, and they're clearly aligned on what this API is supposed to do. And this is not just something which we're just evangelizing. This has been used by many companies, and especially companies that want to scale in their API development processes, right? So for example, this is used by PayPal. It's a well-documented process which they have, and it's published online, where they go through this very, very great intensive process of making sure that the new services they're building align to their business taxonomy. They design that service, so that design, again, doesn't touch on back-end business logic. You're first making sure that this actually satisfies the business needs. And then they go through a verification process, and only then do they start building this API, right? So now let's talk about the next phase, which is documentation. So documentation is really important, and it's not just because, again, you want to make sure that people can consume this API, but it also is just, it's not just consumption, but you're also making it unconsciously, you're making this self-serviceable and sustainable. You don't want to build services which no one can use. You don't want to build services that you'll use for 1 month and then everyone will forget about it. It's a complete waste of time, and it's not good use of your developer resources, right? So documentation is important because it helps keep your external stakeholders aligned on what this API is supposed to do, and makes it easy for them to consume this API. And the cool thing about the definition is that that green box you're seeing on the screen, that can actually auto-generate your OpenAPI, your API documentation, and make it interactive so that your end consumers can come in and understand how best to use this API. So again, some good quick the reason why the definition-driven approach for documentation is pretty awesome is because, one, because the OpenAPI specification is machine readable. There's a huge tooling ecosystem out there, and by tooling, I just don't mean commercial tools, open source tools, free tools that exist. One of the more popular ones, including Swagger UI, where you can just essentially auto-generate your OpenAPI, your documentation right from the API definition. You can host it anywhere you want, because again, some of the open source tools can just come in and you can essentially put it on whatever server you want, and it's fully interactive if you're using tools like Swagger UI, right? Where Swagger UI is an open source API documentation that essentially allows you to interact with your the documentation that's generated from the definition. So this, for example, is just some of the examples we have. So there's the Uber API that's been documented in the Swagger UI. There's also the Marvel API. So this is Marvel's official API documentation. And again, this uses the open source Swagger UI for the documentation. And I think this is the IBM API as well over here, which is using the Swagger UI. So there's a lot of different big companies out there which are using the open source Swagger UI to document the APIs. Then, of course, is virtualization. Now, virtualization is something which is picking up a lot of traction right now, especially as companies want to move faster, but also want to get that early feedback when they're building out their services and developing their services, right? So I think there's some level of the virtualization market does require some education as well. So virtualization essentially allows you to mimic or simulate behavior of components that are unavailable or difficult to access during software development and beyond. So I'll give you an example. Say, for example, you're building an application that uses the Google Maps API. Now, Google Maps is primarily, it's again a third-party service, and they have rate limits associated for every transaction account. Right? So if I'm a developer, I can probably hit the API, assuming, of course, maybe 10,000 times a day. Now, if, say, as you're building your application, you want to do a load test. Now, load test primarily would mean that you have to hit that specific service a lot of times to see if it can handle that stress, right? And so when you're hitting that your application that depends on the Google Maps API, you're essentially hitting against your actual limit that's enforced by Google. Right, so it becomes hard for you to you might have to pay out money. This will affect your development cycle because, again, you're constrained by that 10,000 calls per minute per day number. So virtualization essentially allows you to virtualize that third-party dependency, and during your development or testing process, you can essentially have a virtualized service that mimics the behavior of Google Maps, of the Google Maps application. So this is just one example, of course. In the API first approach, you can actually have a virtualized backend or business logic of your API from the definition, and then essentially have your front end teams work on their front end applications by taking that dynamic dummy data which they get from that from the virtualized API, and also, of course, your backend teams can start working on the backend implementation from the definition because they know exactly how this API works. And I'm sure Nathan will add more color to it during the demo as well. So here's just a quick example of how virtualization could help you, right? With virtualization, potentially you can import that the OpenAPI definition to like tools like say ServiceV Pro with just a few clicks, and you can essentially clone and create advanced scenarios which can then be sent to developers, testers, or other stakeholders as well. These advanced scenarios can be shared to consumers as well of your API. And when I say consumers, internally as well as externally. So you can get initial feedback from, say, beta customers on how this application works from your from the virtualized backend. You can also essentially, with the use of virtualization, advance your development processes as well, because again, as I mentioned, you're reducing dependencies between third-party applications as well as internally, and so you can actually accelerate that process forward. So yeah, this is just showing you how consumers as well benefit from using the virtualization, which the feedback which the end consumer gives can then be sent back to the developers and testers so that they can build a better application and eventually get that into the market. So again, advantages, I've touched on all of these things during my discussion on virtualization. It reduces dependencies, enables parallel development, so make sure that different teams can work together, and essentially faster prototyping, especially if you're a startup, right? You want to move fast, you want to get things done, and you want to get your MVP out there in the market. So tools like SmartBear, for example, has tools like ServiceV Pro, which is one of the more advanced tools in the market, which is also easy to use, where you can essentially overcome third-party limits and reduce any sort of third-party risk and test and develop services much faster, right? And the cool thing is you can do it both locally. You can create virtual services fast, locally, as well as on the cloud. And you can virtualize APIs or even databases with very little or minimal configuration. And all of this is translated from the definition. So you just import the definition and you can virtualize it just from the definition itself. So again, the definition opens up a lot of possibilities and doors for you during your development and testing cycles. Then let's talk about coding, right? So, I mentioned how the definition helps you design that service for your end consumer. You could potentially auto-generate the documentation, make sure that it's consumable. You virtualize your API, your application and the API dependencies, and get that early feedback from your end consumer. Now let's actually start thinking about how you can build that API's business logic. How do you actually develop this API? Right now, one of the big reasons why the original Swagger specification and now the OpenAPI specification has really taken off is simply because of how you can actually prototype much faster by generating server stubs or client SDKs directly from the definition. And I'm not kidding when we say there's some really great tools out there like the Swagger Code Gen, which is completely open source. There's there's other OpenAPI code gens out there that essentially allow you to generate your API business, so your API server stubs as well as client SDKs, all directly from your definition in over 30 different languages. And all your developer has to do is go in and add the business logic, maybe with some minimal configuration, depending on how your architecture is, but just focus on the business logic and get stuff done and move fast. Right, so it's really fast, helps a lot in in the prototyping phase and making sure that and getting your API out there. So from the code generation, you can either create server stubs for your developers to actually start building the API. So, all the manual configuration, the routing, the controllers, and all of that is already taken care of during the code generation process. And all your developer would have to do is just go in and focus on the business logic, the request and response cycle. or it could be the SDK, right? So at the end of the day, you want your services to be consumed by people, and internal or external. And the more SDKs you can provide for their favorite programming languages, or the programming languages they're using, their applications, the applications are built in, the better it is for them to integrate with. So you can actually generate SDKs, which you can then configure depending on their use case, and deliver a much better consumer experience. So advantages of the code gen process, right? No time wasting on boilerplate code. Let's just get to the point. Let's just use the code gen process and move faster. It's just like the faster prototyping. And it's, again, out-of-box SDK generation for easy consumption. So in the code gen process, you're looking at both internal development as well as external consumption. And it's done in over 30 languages right now, and it's ever evolving. So if anyone wants to contribute to the Swagger CodeGen project, it's completely open source, and it's available on GitHub for anyone to come in and build. Finally, we have testing. So notice, of course, that I'm not talking about deployment in today's webinar. And the only reason for that is deployment deserves its own special topic. I will just add one note, which is from the definition, you can actually abstract your deployment process by generating, for example, with OpenAPI, or the cool thing about OpenAPI is that you can add extensible services, which can then be consumed by external tools like runtime management tools like Apigee or AWS. And so essentially allow you to deploy your APIs, and have them on that runtime infrastructure much faster and easier.
Someone was just asking a question in the chat about support for serverless applications, which I know that we just rolled out an integration for, but I think Swagger ties really nicely with that. Something like an operation name, we can map to a serverless function and kind of keep everything in line that way. So yeah, a lot of flexibility.
Yeah, and Swagger Hub integrates directly with Lambda, for example, where from the OpenAPI design in place, you can essentially, with a click of a button, essentially push that definition to your AWS API gateway. And because it's directly integrated with Lambda, Swagger Hub, all the different methods and endpoints will have an associated Lambda function automatically routed on the API gateway. And so you just have to go into Lambda on the AWS API gateway and put in the actual serverless functions and get the API running. So I think we did a webinar on that last year. So that's something you can check out in the Swagger.io blog as well. So testing, now let's talk about quality. Quality is really important, and I talk about every phase is important, but this is probably one of the most important phases, because no one likes it when your API breaks, right? And it's especially in this platform economy. Think about it. Say for example, when you're streaming Netflix, if a TV show doesn't stream in under 5 seconds, you're angry. We've as a generation, we've just become a lot more impatient. And so testing your definitions, testing your services for load, for making sure that it's not vulnerable, and essentially making sure that it functions and works as intended is really, really important. Right. The cool thing is, the definition-driven approach, you're helping your testers a lot, your QA engineers, or even your developers who are, if you're in a startup, they're doing both. Or you're essentially, with the definition in place, you can actually quickly generate test cases directly from the definition, from the API's contract. So a tool like, for example, Ready API or SOAP UI, they will consume the API's definition, automatically create test cases, and allow your testers to test. Now, many times we get this question, which is what if my definition changes, right? An interesting anecdote is a big reason why OpenAPI became really popular and adopted a lot is because it reduces handoffs. And so you can actually, as the definition changes, as the design changes, as the functionality changes, if your definition reflects those changes, this is why you got to go follow the definition-driven approach. Anytime you make a change, you change the design or the definition first. You can actually refactor that into your testing suite, like say SOAP UI, and it automatically updates the entire process. So it's really easy to refactor as well. Some advantages of testing from the definition. One, again, reduces time to market by generating quick tests, and really helps you minimize confusion between the development and the testing process, because you can tie back really, you can merge those two processes together. You can tie it back really effectively by refactoring different changes. Finally, mitigating risk. Right? You don't want your applications to break in production. No one wants to do that. And while it's cool, it's funny to say, I test in production, it's not really great for your end consumers. So that's why it's important that we have a tool. SmartBear has a tool like Ready API, for example, where you can essentially you can get started with minimum training and skills. We have an open source version like SOAP UI as well. If any of your startups or open source aficionados want to get started as well, fully open sourced, you can come in, consume the definition, and start testing your APIs. So this really covers all of the different phases. And I know we have the next 30 minutes. And so I want to actually work with Nathan to actually walk through the demo, which we have to show you how you can actually adopt the definition-driven framework in a practical real-life scenario. So in this case, we're going to be actually talking about, for the demo, we're going to be showing you a couple of different tools. So of course, there's going to be ServiceV, which we'll be showing you as well. And Nathan's going to take a deep dive into that. We also have a tool like Swagger Hub, which is essentially a way for you to think of it as an API development platform for your design and documentation needs. The cool thing is it's built for collaboration, right? So it's built for sharing your definition across your team. And as I showed you before in some of those previous slides, you have all of those individual phases like design, documentation, testing, deployment, and all of them foundationally touch on the API definition. So think of Swagger Hub as a source of truth for your definitions and keeps all of these different stakeholders aligned, and it integrates with all of their tooling, and as we'll show you in the demo, and essentially helps you build APIs faster, which with consistency, with discipline, and creating amazing consumer experiences. So the demo scenario we're going to be showing you is just a quick example, assuming we're in Star Wars is really popular right now because Disney's really overloading with the films. So let's talk about the Dark Corporation. So let's see that. So in this framework, the Dark Corporation has been around for 100 years, right? But they're seeing that, hey, everyone's catching up on the digital transformation and they're kind of behind on that. So they have a new architect who says, let's actually take a modernized approach and move forward, design first, or definition first, right? So have a definition in place and have essentially allow all of our services to talk to each other so that they can build applications faster. So their objective is to create a new API that retrieves information from the Dart book library. So they've learned a lot in the last 50 years of their existence. And so now they just want to make sure that there's an easy access to the knowledge that they have from their library. They want to get early feedback by virtualizing that API. And then from there, they want to make sure that this API works so they can quickly build some tests. So our approach is going to be very simple, which is you're going to take Swagger Hub, design this API in Swagger Hub. You're going to auto-generate the documentation as well as some of the coding, and the application backend. And the cool thing is, while all of this is happening, you can also virtualize the API using ServiceV, as well as make sure that this API works as intended functionally through Ready API. So this is just, I'm talking too much. I'll give it to Nathan right now, who will actually walk you through the real demo.
Terrific. Great. So as Keshav kind of mentioned, we're going to walk through some different phases here. We'll get started. We'll talk a little bit about the definition and some of the documentation that gets generated as I write that. But then we'll see how we can feed this into something like our testing and our virtualization platform as well. So up on the screen, as opposed to meeting everybody sit here and watch me type one of these up, we've got a little API definition here for exactly the use case that Keshav mentioned. So here on the what do you call it? The Death Star, we've got a brand new library. We want to have everybody be able to access all of the information in there. It's a very forward-thinking company or space, so it's all API driven. Now on the left-hand side, we have all of the different methods, resources, all of the different kind of expected parameters and values. And there's a couple of things that I want to point out here, which are really going to kind of facilitate larger API design and development. One of them is going to be extrapolating values away from the actual function of the definition. So instead of us saying, okay, we've got a response that is a 404, and here's the object that it returns. If we have multiple different services, multiple different endpoints, we end up reusing that definition a whole bunch of times. We end up, copy pasting it over and over again. When we need to make a change, when we have a new version, or we realize there was a typo in that initial kind of type up that we did, it sounds like a lot of work to go and have to find every single kind of reference to a 404 and have to update them one by one. So I think one of the key pieces here that I want to mention is the idea of having a definition within a definition. For me to be able to take an object or parameter or response, something that I know I want to standardize and reuse, and be able to store that as its own object that we can then call, I think is really powerful. Now we can see here that we've got a couple of these, one for an individual object, one for an actual response. These could be stored within the same file if we were using the open source version of the Swagger Hub or the Swagger editor. It would just be right down at the bottom of the file here. In this case, they're actually kind of moved out to what we call a separate domain. So it's a space where we can call them from multiple different APIs. So if my 404 is something that's organization-wide as opposed to just API-wide, just one place that we can start to take advantage of that. And again, this is going to help us kind of standardize across the entire platform and organization. Really, really powerful. So I don't want to spend too much time working in Swagger Hub here. I don't want to spend a bunch of time looking at building out the definition. I think it's going to make much more sense if we take a look at what we can do with this definition once we've created it. So we could go ahead and save this. From this point, there's a couple of things that we could do. We could generate some client and server-side code. I know that someone asked about generating like a JavaScript client. We have that capability either within Swagger Hub or within the open source tooling. We can absolutely, have our API written up. It could be coded in, Python or whatever it might be, but then we have our client application in something totally different. Well, we can make sure that whatever it is we're generating, that scaffold that we're building, as opposed to just being like a standard template, we can actually have it kind of create some objects and create some, create some methods and create some different, some controllers and that kind of thing to define how we interact with that API. For our use case today, let's go ahead and move it over into our virtualization platform. So as opposed to downloading this and then re-uploading again, we're just going to make a web call here. Let's just verify that I can type this correctly. There we go. So we're going to pull this down. And again, this definition could be JSON, it could be YAML. The idea here is that it's in a standardized format that we could parse through. It could be our, and we saw it there on the screen, it could be our documentation portal that is using Swagger UI. That's what's rendered out on the right side of the screen here. We could host this totally separate from kind of Swagger Hub or from the editor itself. I think we saw the Marvel API has something very similar to this, where it's just a slightly customized Swagger UI hosted in their own kind of space, and it's just hooked up, I imagine, to a Swagger definition behind it. So if we want to start thinking about moving this into other applications, we can use the back end of the service. Let's go ahead and just create a new workspace for us to get started in. Create an empty project here. So we can bring this definition down. Again, because it's in a standard format, we're going to be able to read right through it, and we'll get a little collection or a library of the different requests that we can make. Now, what's not immediately kind of shown to us is that we're actually storing the entire definition behind here. So if we, let's say, wanted to build out an assertion, as opposed to us saying, okay, here are all the expected values, here are the maximum string lengths for everything in that definition, we can actually just map the assertion to the definition itself. It'll read through it. It'll say, okay, here's the resource I made the call against. Here's the response status. And here's the expected values. So there's some really cool capabilities there, and we'll explore that in a little more detail in just a second. Before we get into that, I just want to point out, again, because it's defined, expected values or path parameters, that kind of thing are going to be given to us right in the editor. This is also the starting point for what we're going to do in the virtualization space. So as I mentioned before, we're storing behind us the requests, the responses. All we should really need to figure out is, okay, what is the logic that serves up a particular response based on the request? A tool like ServiceV is going to do a really nice job of kind of facilitating that. We can right-click on that definition that we just brought in, pick and choose our methods. And when we're moved over into that virtualization space now, we see we have a pretty straightforward layout. On the left-hand side, all of the requests that we're going to be listening for, again, method, resource, and this is, again, pulled from the definition. We have on the right-hand side a collection of responses. In my case, it's a 200 and a 404 for every single call that we're making. And now all I'd really have to do is go into the center here and say, okay, what is the logic? What ID do I consider to be passing to give back my 200 as opposed to a 404? Now, there's some flexibility here. If it's post request, we can very easily map to something coming in the body. In our case, we know that it's a path parameter. So let's go ahead and say in my path, if my ID is equal to, I don't know, what's a good number? 666. And we'll return, make it lucky. We'll return response 1. Right up in the top, anything outside of that range, we'll go ahead and return response 2. But with just a couple clicks of the mouse now, this service is listening at localhost 8088. I know exactly the path that I can make a call against, and I know the value that should return a passing kind of response. So now when we look at this from the higher level, and let's make that call, we get back that 200. And anything outside of that, again, 65, here we go, or even just a single number, this is returning that 404. So again, as opposed to me downloading the code bundle, creating some logic, mapping it to a data set, connecting it to a database or something like that, potentially, you know, a good few hours worth of work, we did all of what we would have done through coding in just a few minutes using this visual editor. So this concept of virtualization, I think, is really powerful. You know, we're showing you ServiceV. It's a very straightforward, easy to use kind of platform, but we don't necessarily have to use this. We could absolutely be virtualizing in some other spaces as well. I think what we're really showing here is how easy it is to use something like ServiceV to kind of facilitate that. And again, now we can tie this into our testing platform. Let's see, from here we can just go ahead, right click and generate a test suite from this point. As I mentioned before, we can stand up all of the assertions that we expect to run. So when we look within any of these requests, and we open up our assertions that are going to be executed, that Swagger compliance assertion, we essentially just load in that same Swagger spec. And now whenever we run one of these requests, we get a response, it's either going to pass or fail based on what's being returned. So let's see if I can get this to break. We change our expected response here, and I might not have required any of these fields. There we go. So there we go. So change the status code that was coming back, just a 405. We can see that the status is still coming back here. So if I had initially created my assertion against the response, this right now will be passing. I would never catch the status code in the header is actually coming back in a different value. Because this is, again, tied to my definition and I don't have a 405 in that definition, then we're catching that right now. And there's only a single assertion I had to build out. You know, I've seen this used to say, okay, this is the maximum string length that I have in this message, something that I would otherwise have to read through documentation and kind of manually build out. Now we can tie it again to that contract or that definition that we've been writing against. Now, when we look at ServiceV or virtualized service, there's a couple of things that we can start to think about. One, you know, it's very rare that these would respond immediately. I think my latency there was something like 13 milliseconds. If this was running on something like the Death Star, that's obviously up in space. It's going to take quite a bit of time for it to get a response back to us. So we can definitely mimic the latency. We can mimic a certain amount of server capacity that we're going to be able to support. Really powerful if we're going to be running this as some kind of load test or early stage load test, maybe as we've spoken about before, removing a third-party dependency. It's a really, really useful way to kind of mimic the actual service. Transaction log, exactly what it sounds like, very useful for us debugging anything that's going on here. If it's not responding correctly, well, now we can open this up and see exactly why. One of the capabilities I think is kind of interesting, and this is getting a little more advanced than just that import stand-up mock service, is actually tying this to something like a dynamic value set. You know, if I had a database with all of my values, if I had an Excel sheet or a CSV file that just had a stack of values in it, and these would drive some of the responses. You know, maybe I don't want to hard code everything and create all that logic. Maybe there's something that should be generated dynamically. Well, with something like ServiceV, we can actually mimic that by creating a little piece of logic behind the response itself. So here, let's imagine that we're creating something like that book ID that we know we're going to return. I could have a collection of these in an Excel file or in a database. In our case, let's just go ahead and generate these at random. There we go. Now, when we look back again at the response, we can remove this hard-coded value. And we can go ahead and create a connection to that data source piece. And when we look at this reference, now it's going to serve back a different value every time we make this call. And this might not seem very useful kind of at a high level if we're just building this out to run simple requests from within the application. But let's think that we're, writing some tests against this from outside. And if this was always returning the same value, there's a good chance that I'm just going to hard code. I expect 86 or 95 to come back. Well, if this mock service is actually responding with dynamic data, I'm never going to get that point. That's never going to reach it. That's never going to get written into my test harness or my test suite. I'm going to have to know that that value is going to be dynamic and that it's going to fail every time if I've set a hard code. So again, something to kind of think about building on top of these mock services, these virtualized services, that I think really opens them up to a little bit more than just, okay, we submit a request and we get X response, and we submit Y request and we get Y response. We can actually have this look a little bit more like a service, and actually, give us some real value as part of that. Now, the one question everybody asks at this point is, Nathan, this is running locally. This is only really useful for me. If I have a development team, I'm working in some kind of agile process or something, I don't want to have everybody maintaining these mock services on their own machines. That, again, is adding more work. It's adding more maintenance. It's not very useful. So what we actually provide is a hosted space that we can deploy these to. Down at the bottom here is this component that we call Virt Server. We can see that we've got a number of these already running, but I can take this thing that I've developed locally, that I know runs in my test suite or that I've written some code against, and I can take it and deploy it down into this shared space. Now, when I run this, it's accessible across the entire network. So really anybody's going to be able to hit this and get some responses. So if I'm, a front-end developer, I can write some scripts against this, start to render out some data as opposed to just creating, like a mock interface or, just a template or something like that. It can actually work with some real values. If I'm a tester, well, now I can write my tests against something that's live. If I'm a back-end developer, I'm building some integrations or something with an upcoming API. Now here's an endpoint for me to write against. When the actual service is live, really all I would have to change is probably where this is being hosted. So again, some really powerful implications when we think about taking this from that local machine into that shared deployed environment. And we make this process pretty easy with this combination of ServiceV and Virt Server. But I think just thinking about it at a high level across, the development process, it will pay dividends and will give a lot of value back with potentially very kind of minimal time sink at the beginning. So, Keshav, I don't know if there's been any questions or anything that's been coming in. We want to take some time. We've got about 10 minutes left here.
Yeah. I think we can now actually start opening up the room for questions. And let me show you. Actually, we also have a quick resource section which you can show. I'll show. Let me steal your screen, Nathan. I don't mind. Unless you've done finished your demo.
I think so. Yeah, we covered it all.
It's
Here's one I can answer while you're getting this going. Is it possible to run the virtualized services from Ready API in a standalone way, for instance, with Jenkins? Yeah, absolutely. So everything that we've talked about so far, we've been doing through this nice clean UI. Besides from the actual import and creation of the logic, everything else, the starting, stopping, the deployment of these services, that can all be handled through the back end of the application. So usually this gets tied into something like a CI or a CD process where we dynamically stand up these services, maybe when our production or testing environment, something gets taken down. So there's some kind of monitor, or we have some kind of process saying, okay, now start this virtual instance when X happens. So yeah, absolutely something that we can do through a CI or CD process, something like Jenkins.
There's a question on once you lay out all the business logic in a given API definition, how do you merge all the existing logic into new interface definitions? I can actually take a crack at that, and Chris, correct me if if this aligns with your question. But one cool way which we've seen how companies actually adopt design definition first and refactor changes is by using code repositories really effectively. So you start with the design, assuming it's a new API. Start with the API's definition, generate the code. Maybe once you build on the business logic, push it to a code repository. Now, when the time comes for you to update this definition, you can actually create a new version of this definition. And the cool thing is the OpenAPI supports versioning inbuilt. So you create a new version of this definition, you generate the code, and then when you have to push it to these repositories, you can actually cherry pick the right functionality that needs to be merged. So you don't have to fully merge everything. Really, as you update your definition, you can cherry pick what needs to get changed and what doesn't need to get changed. So this is something which we've seen our clients perform effectively. And of course, like, this is a very broad statement. It really depends so much on like the actual use case, but this is something which we've seen happen.
And yeah, and Nathan, I was wondering, or Kisha, if you have the screen there.
Oh, he has the screen.
Someone earlier was asking about kind of if we could show example of just showing the code generation from within Swagger Hub as an example of that.
Sure.
It sounds like maybe they're familiar with the code gen tool, but how does that actually look in Swagger Hub?
Yeah. So we've got this definition here, and let's say that we wanted to stand up, one of these code gen bundles. I'm a big Node guy, so we'll go ahead and pick this Node server. Now, one of the nice things this actually does when we kind of crack this open, and see, I was doing this with Python a second before, it's actually going to act as a documentation portal out of the box. So I could go into this directory and I could stand this up. It's just essentially start the service, and it's actually going to render out that Swagger UI component immediately. So without me actually having to figure out how to, pull down and kind of invoke Swagger UI, that is all now tied to that definition that we created. Now, once we actually get in here and take a look, we have some models. We have some different routes that have been created for me. And this is going to be different depending on the bundle that I bring down. So again, this is the one that I use all the time and I feel comfortable with. But we could definitely have other options on here as well.
Yep. So there's a question on when will Swagger OpenAPI 3.0 tools come out? What is the timing around it? There's actually many tools already that exist. Like if you go to openapi.tools, you'll actually find a huge list of tools that support OpenAPI 3.0. I know there's like some tools that need to catch up. I think API management tools like AWS, for example, API Gateway still supports only 2.0, but they are actively working on 3.0. And so we're very confident that hopefully in this year, we'll see a lot more tooling as well. Will it have parity with 2.0 tools? There's actually like all of the Swagger open source tools actually has parity both. So it's like 2.0 as well as 3.0. So I'm pretty, again, like it really depends on the tools you're using, but there's already so much progress happening in the industry on that front.
Nathan, I saw a question. So we showed 3 different tools today. Someone was asking specifically about, if they wanted to play around with these tools or use these tools. I mean, is it 3 different downloads? It's different sign up? Could you maybe talk to people some of the differences there?
So we talked about Swagger Hub. This is a cloud-based solution. So just access it in the web browser. When we actually get into the testing suite, Ready API is a single application. So you'll download this and install it, run it. It'll run on pretty much any box, Windows, Mac, Linux, whatever it is you have. But it's going to include everything that we've spoken about. So the testing harness or the testing side of things in SOAP UI. It also includes the server side of that, which is ServiceV that we kind of walked through. Virt server is something that runs separately. This is just to allow people to deploy this in something like their own server space or in the cloud if they wanted to. So we actually can communicate with the Virt server, but it is something that's kind of stood up separately. We've even seen some teams kind of push this up into a container and dynamically spin that up. So some capabilities there. The one thing that we haven't mentioned is another aspect of the tool, which is the performance testing piece. So, we have the definition. We can create this little kind of sequence of steps in SOAP UI. We can run that at scale very easily from the load UI piece as well. And again, this is all just a single application and install. They're licensed separately. We found that not a lot of, not everyone who uses like the testing side will necessarily need to use ServiceV and kind of that space. So they are licensed separate from one another. But the application comes as just a single download.
Awesome. Thanks so much. And for anyone on the line, we did just launch a poll within the webinar so that you can actually see. So if you're interested in receiving information about any of the tools specifically, feel free to respond there. We'll make sure that we send you some more info. I know we gave kind of introduction to some of these here. Let's see any other questions that have come through.
There's a question, are there any tools to convert an existing service class to YAML file?
Service class like something like Swashbuckle or something where we annotate our code, our classes, and map that to like a definition?
Yeah, it could be that.
Yeah, there's definitely some out there. it's really language specific, or I guess I should say framework specific. Like, if I have .NET, it's going to look very different than a Ruby Rails application that I want to generate Swagger from. So yeah, there's a bunch of libraries out there. The general gist is that you annotate code or classes with what you want to spit out into the Swagger file, and then at build time or compile time, it will generate that as like an artifact of the build. So yeah, it really does just depend on the kind of framework or the language that the class was written in.
Looking at in the webinar registration, we'd asked for some folks to submit questions. I thought this was an interesting one, maybe you could speak to. Someone was asking around, they're already using the open source Swagger tools. What's the benefit of, we just showed the Swagger Hub platform, and what's the benefit of using that as compared to just, setting up and running those tools locally to, do some of the definition work you talked about? I don't know if either of you guys have any thoughts on that.
Yeah. I talked to a lot of people about Swagger Hub, and 90% of them come from using the open source tooling. The open source tools are great. I think it's fantastic that we can all run them separately on our own individual machines. But when we think about doing that at scale, when we think about teams and when we think about different teams trying to work together, communicating these definitions and maintaining something like a default version, that's when we start to run into problems, and Swagger becomes more of a hindrance than it really becomes a benefit. Now, when we have a repository system or a shared space that's going to control and kind of organize all of that information, allow us to kind of assign permissions and kind of move that definition from group to group, I think that's when we really can accelerate some of the advantages that we find with Swagger platform or with the Swagger tooling. Kishore, I don't know if you have a different answer. I know you talked to some different people about that.
No, I completely agree with that. And the whole thing is like, as your organization scales your API development, it becomes harder and harder to like use individual tools. You need something to tie in different processes together. You need something to make sure that the APIs are consistent, they follow the right style guidelines, and essentially work together as a team. So that's where Swagger Hub comes in as a central source of truth for API definitions.
Awesome. Thanks so much, guys. Let's see.
So we have one question, which is, we've adopted JSON-APIs.org. Do we have OS 3.0 accelerators libraries? Personally, I can't think of anything on the top of my head because the ecosystem, again, is huge. I would definitely urge you to look at OpenAPI.tools, which has a list of all the libraries and tools available. I don't know, Nathan, if you have any other answer regarding that.
No, nothing off the top of my head, unfortunately. But I do the same thing you do. I just go to that web address and start hunting through. So it's probably the best resource.
Yep. We saw just a few questions, people still asking if we're going to send a recording. We'll definitely send that along for everyone. Hopefully, for everyone who's been able to tune in, hopefully you've been able to get some of the good insights you're looking for. We've also received a lot of questions around timelines and support for some of the different tooling that we offer. We have both a mix of open source and pro tools. I know Kishore touched on some of that, but we'll do our best to share as much information we can there. And I believe Kishore also shared a link that we have repositories for all the open source tools that have some additional information. All of the tools that we talked about today do have a trial version, so we can certainly send some links along to some of the folks if you want to test out any of these tools. I think at this time, we're just about at the limit here. I want to be cautious of everyone's time. I think we're at a good point where we can kind of wrap up. As I said, we will be sharing a copy of today's recording. We'll certainly be following up with some additional information based off some of the tools and topics that we talked about. You can always get in touch with us either on our websites on smartbear.com or on swagger.io. And you can also make sure to follow along on our blogs and on our site with the latest information. We're always we host webinars like this on a weekly, bi-weekly, monthly basis. So we have plenty of trainings going on. But at this time, I want to say thank you to our presenters for this great presentation, and thank you everyone who took the time out of their busy schedules to tune in today. So thank you so much.
Thank you all.
Thanks, everybody.